You were watching the Target 6.2 retest video. We're going to take care of exponents, rational exponents, how to write them in radical and exponential form. We're going to do exponent properties. This one is very large. So sit back, get your white packets, take lots of notes, do the problems that we're going to do, rewind it and watch it again and again if you need to. And then on top of that, if you need additional help, go see your teacher before or after school. All right, here we go. The first set of problems has you express things in rational radical and exponential form. So on this side, they want us to do it in radical form. So this is exponential form. On this side, they want us to do it in exponential form. So this must be radical form. Notice that in exponential form, we have fractional exponents, where this number is the power, this number is the root. It'll become a little bit more explanatory in a little while. Over here, this is radical form. This number is the root, this number is the power. So the number on top, the power, goes on the outside of the parentheses as power. The number on the bottom, the root, gets placed in that little place right there. That tells you what root we're looking at. When you don't see a number there, that is a square root. So writing this in radical form has us put a root sign. It's the second root, but usually you don't put that there. So I will erase that. It's just known if you just write a root that it's the second root or square root. The 6m goes underneath there, and then the fifth power. So the power, the root. So negative 2/3 then adds a different little twist to it. That negative sign means reciprocal. It does not mean that you have a negative number whatsoever. A negative in the exponent means that you have a reciprocal, which is to flip the fraction. So we have the third root of 5x. All of that is to the second power, and since we need it as a reciprocal, it goes on the bottom of the fraction. And now going the opposite way, we have 2r is the term. We have the third power, and remember the root goes on the bottom, so it's the 3/5 power. This one looks like the second one before. This needs a reciprocal, which is the negative exponent. So we have r, fifth power, fourth root, and since it's a negative exponent, we need to put a negative sign in front, negative 5/4 power. All right, so that's how you work back and forth between radical and exponential form. I know there's some more problems on that worksheet, so you might want to just pause the movie, do the rest of those problems, and then we'll move on. Right here is 16, 17, and 20. This one has you simplify, which just means let's take the fourth root and the third power of this number and get an answer. So really, we're trying to do the fourth root of 625. The fourth root of 625 is 5. And then we need to take care of the power. So this would be 5 to the third power. That's 125. If you were given a power sheet by your teacher, you would look under the fourth column, fourth power, fourth root, and you would find 625, follow all the way over to the left and you see 5, and then 5 to the third power is 125. Okay, for 16, we're doing 16 to the 1/4 power, or if you prefer it this way, the fourth root of 16. Look under the fourth column again, you see 16, you follow it all the way over to the left, it's 2. And then we take 2 to the fifth power. So find 2 all the way to the fifth power. You can go 2 times 2 times 2 times 2 times 2. That's 32. And then don't forget that negative. That means reciprocal. So instead of 32, our answer is 1/32. Last one here. We want to do the cubed root 27. So either way that you like to see it there, you will get 3. Get rid of 27 is 3, and then 3 to the 5th power. 3 times 3 times 3 is 27, times 3 is 81, and 81 times 3 is 243. And then don't forget that negative, which means 1 over 243. Notice there's no negative answer, there's no negative numbers, it's a negative exponent, which means reciprocal. All right, I know there's a ton of problems like those. Feel free and pause the film and then do the rest of those and come back. We'll hit the rest of the exponent properties. All right, in order to do the exponent properties, you need to be able to recite what a power property, what special exponents means, what a product property, and what a quotient property is. And I'll be talking about those as we do some of the bigger problems. So the power property is the dead giveaway is the parentheses with an exponent. And all that means is that that exponent needs to go to all of the exponents. Now notice the 2 doesn't have an exponent. It still is there though as a 1. It's 2 to the 1st power. So one mistake that I usually see a lot of kids make is instead of multiplying with negative 3 times 1, you get to do negative 3 times 2. Oops. It's just exponents. Exponents need to multiply with exponents. So that negative 3rd power goes to all the pieces. Okay. Now this one isn't quite done, but you'll see as we go through, we're going to use the special exponents property to take care of the rest of that. So let's see what the special exponents property is. Special exponents are the negatives or the zeros. One of the two. And remember, the negative exponents just mean reciprocal. So this is 1 over 6 squared. This is 9 to the 2nd over 1. The 0 exponent just means that everything is equal to 1. So since all of those would get to 0, it's just equal to 1. So that'll be the second step in most of these problems. The product property is, the dead giveaway is that there's no parentheses. We're just multiplying 2 terms. So 2 times 2 is 4. X squared times x to the negative 3 deals with those. That's x to the negative 1. Y to the 1st and y to the 4th. If we combine them under one exponent, we have y to the 5th. And z to the 3rd and z to the 7th, if we combine them under one exponent, it's z to the 10th. Now, how does that work? Let's look at the y's, for example. We have 1y here. Y to the 4th repeated multiplication shows you this. So if we combine them under one exponent, you would have 5 of them, hence the 5. Okay, so same with the z to the 10th. If you can picture z, 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 and then 7 more z's for the second z, you're going to have 10 of them total. Combine them under one exponent, z to the 10th. So if we use that shortcut of combining exponents, 2 and negative 3 makes negative 1 for the x's. And notice we didn't go 2 plus 2 to be equal to 4. It's 2 times 2 equal to 4. Those are not exponents, those are coefficients. So that's the product property. And then the quotient property has to deal with the division. So notice that 2 divided by 4 is 1/4. It's not 2 minus 4, but the way we're going to talk about the x's and the y's here is this. X to the 7th looks like this, and x to the 3rd looks like this. So as you know, anything divided by itself is 1, so that's a 1, that's a 1, and that's a 1, which means we have 4 of those x's left over, and they're on top. Writing them as exponents, it's x to the 4th. So if we think about the y's in the same manner, y to the 10th, there's a lot of y's. I think I got them all. There's a 1, there's a 1, there's a 1, and there's a 1. So we have 6 y's left over, and they're in the bottom. So the way you'll hear me talking about this on the movie is, where are there extra y's after you cancel? And how many are there? Well, there's 6 extras there on the bottom, so y to the 6th on the bottom. Where are the extra x's? They're on top. There's 4 extras, so that's why it's x to the 4th. So if we're going to do these properties, we're going to do them in this order. I would expect to see 4 steps if all of them are used. So let's go to some problems. Alright, so 30 and 32 have you simplifying, so we're going to use the power property. That one's going to come first. So this is p to the first, so we have p to the negative third, q to the negative sixth, r to the negative 12th, 2, because that's 2 to the first, 2 to the negative third, p to the positive 12th, r to the positive 6th. That was the power property. Now we will take care of the special exponents. So the special exponents, I'll circle them. This one, this one, this one, this one, that's it. So those need to be reciprocal, which just means we're going to flip them from the top to the bottom. If they were on the bottom, they would go to the top. So our next step, these are the ones that aren't moved. These are the ones that are moved. Notice their exponents become positive. Next is going to be the product. In this case, if you look across the top, there's nothing to combine. If you look across the bottom, there's nothing to combine. So really the problem doesn't change. Usually in this step, I will do the numbers. 2 to the third is 8. And the last step is the quotient property. So we'll look top and bottom. Basically we go this way. So the numbers is still 8 on the bottom. Look at the p's. We have 12 p's on top. P, 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 and 3 p's on the bottom. So when you cancel out, 3 of them cancel out. You're left with 9 extras, and they are all on the top. Looking at the q's, there are no q's on top. All the extras are on the bottom. And then the r's, there are 6 extras, 6 more of them on the bottom. So the extras are on the bottom, we leave them there. There is our final answer. Notice 4 steps. Power, special, product, quotient. Let's do it again on this problem. Power property. Special exponents. Here's one. That's the only one. So I'm going to write 2 to the third, z to the third, y to the ninth. 2 to the third, y to the ninth, z to the 12th, and then the x to the 12th goes to the bottom. The product, that's looking at the top, nothing can change there. Write them in order. Look at the bottom, nothing combines there. Write them in the same order. And now we do the quotient property, so we look up and down. 8 divided by 8 is 1. It cancels out. The x's, there are 12 extras on the bottom. The y's, there's the same number, so there's no extras. So they just disappear and cancel out. And then the z's, there are 6 extra. They are on the bottom. So we have to put a 1 on top to hold its place. And there's our final answer. Again, rewind it, look at it, see what you can do. Let's move to the radicals. These end up being pretty easy if you understand the exponent properties. Remember, this is the third root. So third root, the root goes on the bottom. So if we spread that out to all of them, it's 8 to the 1/3 power. Here's the power. And this is the root. So that's 8 to the first, so it's 8 to the 1/3. M to the 6/3. P to the 3/3. Q to the 9/3. Again, we're just putting the power on top, the root on the bottom. Now we simplify. The 1/3 power of 8 is 2. So it's a cubed root. And then 6 over 3 becomes 2, 3 over 3 becomes 1, and 9 over 3 becomes 3. That's your final answer. Reduce the fractions, you're good. So again, root powers. So it's 625, first power, fourth root, a to the 12th power, fourth root, b to the 8th power, fourth root, c to the 16th power, fourth root. The fourth root of 625 is 5, and then reduce fractions. Done. This one and the next one is peculiar because it's got a few different pieces, some of them on the outside. So this one doesn't have an exponent, but it is the fourth root of 81. It's the fourth root of x to the fourth. So fourth root of y to the fourth. So fourth root of z to the fourth. And then the 2 is good. And we have the fourth root of 81. Fourth root of x to the 8th. The fourth root of y to the fourth. The fourth root of z to the 12th. Let's simplify. Fourth root of 81 is 3. All of those simplify to the first power. We have the 2. Fourth root of 81 again is 3. And now we can just use the product property to write our final answer. 4 times 3 is 12. 12 times 2, so I'm taking care of all the coefficients. 12 times 2 is 24. 24 times 3 is 72. X to the first and x squared. If we combine them under one exponent, that's x to the third. Y to the first, y to the first. Combine them, it's y to the second. Z to the first, z to the third. Combine them under one exponent, you get z to the fourth. There you have it. All right, a little bit longer problem, but it's just a lot of simplifying. Hey, any questions that you have, make sure that you ask your teacher before or after school. Rewind the video as much as you want and watch it.